Okay, so I'm going to show an example on how to do a 2D momentum conservation problem. So let's look at the exit ticket from class. So in this problem, you have two steel pucks are moving as shown in the diagram below. Determine the speed and direction, angle theta, of the 1.3 kilogram puck before the collision. And the problem already gives us a nice picture. So first thing that we're going to do before we even start solving is find the momentum of everything that we know. So we already know some information. So go ahead and find the momentum of everything you know, and then I will do it on here as well. So let's see. So I know afterwards the mass is 4.2 plus 1.3 kilograms, so 5.5 kilograms. The velocity is 2.3. So the final momentum is going to be mass times velocity, so 5.5 times 2.3, which should give us 12.65 kilogram meters per second. Awesome. So now the 4.2 kilogram, we already know a decent amount of information about that. So the momentum of this, mass times velocity, is 4.2 times 1.8, which should give us 7.56 kilogram meters per second. Cool. And now we want to find the velocity of this one right here. So we know that momentum is conserved in two directions. It's conserved in the x direction and the y direction. We have to look at each direction independently. So I'm going to go ahead and just, we know write out a little more things. So the momentum of this is the mass of this times the velocity, so 1.3 v. We don't know the velocity. So I'm just going to write out an expression for the y momentum of this one and the x momentum of this one. So the y momentum of this one will be 1.3 v times the angle, sine of theta. So this will be 1.3 v sine of theta. While the x momentum over here will be 1.3 v cosine of theta. And I forgot, we also need to find the momentum of this object over here. So using trig, so we know that the total momentum is 7.56. We know the angle is 30 degrees. We need to find the y and the x. So we can use our good old friend SOHCAHTOA. So for the y, let's see, it'll be 7.56 times sine of 30 degrees, which should give us about 3.78 kilogram meters per second. And then for the x, it will be 7.56 times cosine of 30 degrees, which should give us about 6.55 kg meters per second. Great. So now let's go ahead let's go ahead and set some stuff up. And I'm going to show you a little more mathematical way than the way we talked about in class. So let's look at the x direction first. So in the x direction, initial momentum in the x has to equal the final momentum in the x. So in the x direction, we have the final momentum is 12.65 kilogram meters per second. So I'm going to just write that down, 12.65. So now we have two objects moving initially, and they both have some x component of momentum. So let's see. So the 4.2 kilogram, we found that the x component of that momentum is 6.55. So that's going to be 6.55 here plus the x momentum of the other object. And we found an expression for that. That's 1.3 v times cosine theta. 1.3 v cosine of theta. Great. Now, the problem is we don't know v or theta, so we're kind of in trouble. So let's just go ahead and pause for now. Let's look at the y direction. So in the y direction, we know the initial y momentum has to equal the final. So if we look at this in the after collision, okay, is the object moving up or down? No, it's not moving up or down at all, so that means the y momentum has to be 0. So we know the final y momentum. Okay, so now let's look at our initial picture. This object, the 4.2 kilogram object, has an initial y momentum of 3.78 kilogram meters per second down. So that's going to be negative 3.78. Let me draw a line to not confuse these two. Plus, okay, this one is going up, the other object, and we found an expression for that is 1.3 v sine theta. So I'll write that down, 1.3 v sine theta. Okay, so now we have this equation right here and this equation right here. So now this is the fun old thing in physics when we have two equations and two unknowns. So we got to do a fun little math. So I'm going to pick one equation. I'm feeling like I want to look at the x direction first, just for fun. So let's go ahead and solve for v. And now we can solve for v and plug it into the other equation. So I'm going to do some math. So 1.3v cosine of theta equals, take away 6.55 from both sides. And that should give us, let's see, what will that give us? 6.1. So then, let's see, v cosine of theta equals 6.1 divided by 1.3, which is 4.69. So v equals 4.69 over cosine of theta. Great. So now we can plug this expression for v into the other equation right here. So if I plug that in, I'll have negative 3.78 plus 1.3v times, or sorry, I'm plugging in for v, so I don't want v anymore, times 4.69 over cosine of theta times sine of theta equals 0. So now we got to do some fun simplifying. Okay, negative 3.78 is all by itself, plus it's essentially 1.3 times 4.69, which should give us about 6.1. Now we have sine of theta on top, cosine of theta on the bottom. So it's essentially sine of theta over cosine of theta, which we know is tangent of theta, equals 0. So then we have, let's see, 6.1 tangent of theta equals 3.78. So tangent of theta equals 3.78 over 6.1. So then theta will be the inverse tangent of what we just found, 3.78 over 6.1, which will give us about 31.78 degrees. Great, we found the angle. We're halfway done with the problem, or we've done the meat of it. So now we have to find the velocity. So multiple ways we could do it, but let's just go ahead and plug this angle back into an expression we have for the velocity. So over here we nicely found the velocity. So I'm going to plug this back in right here. So we'll have 4.69 over cosine of 31.78. So I go ahead and do a little math in my calculator, and I get that the velocity is equal to 5.52 meters per second. Great. And we got our final answer.